All right, guys. Vertex. All right, guys. So this first page here, this core concept should look very familiar. Yes? Because that's what we wrote down on Friday. Because we talked about it yesterday. We also talked about it Friday. Now, again, on Friday, I said I was trying something new. That was it. I was introducing these equations early. Because I wanted to see if starting with these equations, instead of just saying y is equal to 1 over 4p times x squared, and then coming to this here is going to make these, help you understand them a little bit better. Because what we're talking about today with both of these here is when the vertex is not at 0, 0. That is the big difference from what we are going to do today and what we did yesterday and Friday, is that the vertex is not at 0, 0. The vertex is, well, here would be at hk. Now for this first one, what is the point of our vertex? So 1, 2, 3, 4, 6, 2. Because it's always x and then y, over and up. Now the focus that they gave us is 6, 7, 8, 9, 10, comma 2. And what they want us to do for this here in these first few is to find the equation. Find the equation from the given information. And then towards the end of this lesson, we're going to find the information, the focus, vertex, axis of symmetry from the equation. We're going to go back the other direction. Now they gave us a vertex and focus. Is there something that y'all notice between the two? The y value is the exact same, yes? So when I look at the general equation, which one am I going to use? X equals. Because in x equals, the vertex is h comma k. The focus is h plus p comma k. The k value is the exact same. And we also said when we have x equals and the y value is being squared, it opens to the left or to the right. So this here, we do have the equation, x is equal to 1 over 4p, parentheses y minus k squared plus h. Well, in the general equation, the three spots I need to plug a number in for is h, k, and p. Because if I have the values for h, k, and p, we can have our equation. Because in the equation, we will always have x and we will always have y. Input and output, those will stay the same. Can anybody tell me what the value of h is?
6.
Yes. And where'd you get that? Because the vertex is what? H comma. So what's the value of k? Because if we're given the vertex, we're automatically given h and k. If we're given the vertex, we're automatically given h and k. Now the focus, x value is h plus p is 10, yes? So we know h plus p is equal to 10. Now what did we say h was? So 6 plus p is equal to, so p is? Because we could subtract 6 from both sides and say that p is 4. Any questions on this so far? So at this point here, we can come to our general equation and plug in. Well, it'd be x is equal to 1 over 4 times, well, p is 4, parentheses, y minus what? 2, because k is 2, plus. Any questions on this so far? Okay. Well, 4 times 4 is, parentheses, y minus 2 squared plus 6. Because we can't really add 6 to either one of them without really changing the function. Because I could, but in order to do that, I have to take y minus 2 squared. I have to multiply y minus 2 by y minus 2. I have to distribute all that out, then multiply by the 1/16 so that I can add 6. No, we'll leave it here. Because is it asking us to factor this all the way out? No, it's wanting us to find what? The equation of the parabola. Is this right here the equation of the parabola? We're done. That is the answer. Questions on this here? So we can look at the focus and the vertex, but which of the equations are we working with? X equals or y equals? Which way is it opening? To the left or to the right, yes? Whenever it opens left or right, y is being squared. Is our y equals x squared? When we looked at those graphs, it opened up or it opened down? Because really what we're talking about left and right is that at 0, I have how many points along the y-axis? 2. So here the y is being squared. Now if we look at the focus and vertex, let's look at those. So the vertex here is at the point, well, so -2, -4, so -2, and then up to 4. The focus is at 2, 4. Which one's staying the same? The k value. Since the k value is staying the same, we're talking about x equals. X equals. And again, that key component, that chart that y'all have, especially on the test, I'd write it down on the review sheet and refer back to it, especially on the test. Because again, getting these flipped, the x and y equations flipped, is very easy to do. Okay? But I think it was in here yesterday, I wrote, I think for the axis of symmetry, or no, it was the directrix, I had y equals on both. It was either this class or the next class. I had y equals on both. It's very easy if you're not paying full attention to it. So heck, if you have it written down, go back to it, reference back to it, use it. Because once we get this here, okay, well, exactly, the focus and the vertex are going to stay the same for y. So this is our x equals 1 over 4p, parentheses, y minus k squared plus h. And what variables do we need? We need h, k, and what is the value of h? K. We don't know p yet, do we? But from the focus, I do know that h plus p is equal to what? Or 2, because vertex h's value is -2 plus p is equal to 2. So what do we need to do? Add 2 to both sides and get that p is equal to 4. Questions on this here? So the value of p is, the value of k is, and h is 2. Parentheses, y minus 4 squared and that's it. Questions on this here? We're good with this here? So it told us to focus. Yes. 1 over 4p parentheses x minus h squared plus k. Now what's the vertex at? H would be, K would be. So, exactly, because again, x's are staying the same. So our k plus p gives us the 0.25 from the focus. So we have 0 plus p equals 0.25, or p is so y equals 1 over 4 times 0.25 parentheses x minus 1 squared plus, what is 4 times 0.25? 1. 1 over 1 is just, so that whole thing is 1. Because the 1/4, 1 over 4p is going to simplify completely to 1. So we don't have to write it. The plus 0 doesn't matter. So we just have y equals x minus 1 squared. Questions on this here? Yes. Now the vertex is 4, 2. The focus is 4, comma. So h is 4. K is, because our vertex will give us the h and k. Now the 11/4 will be our h plus p, will give us the 11/4. So for y equals, the focus is h comma Yeah, k plus p. Thank you. K plus p. So again, like I said, I'd keep referring back to that chart to make sure. It's very easily, as I just did, to flip them. Well, k is, so 2 plus p is equal to 11/4. What can we do to solve for p? Plug it in. I'd plug it into the calculator. We can do 11/4 minus 2. Did y'all get the same thing? Because if we wanted to actually subtract them, we needed the denominators to be the same, yes? So we would need the denominator for 2 to be, so 4 times 2 is 8, because 8 divided by 4 is 11 minus 8 is 3. Now, if you can't do that in your head, that's perfectly fine. So, y equals 1/4 times p. Well, p is 3/4 parentheses x minus 4 squared plus 2. 4 times 3/4 is 4 times 3/4 is 3, so it'd be 1/3. Now again, whenever you put these down, the fraction, we cannot have a fraction inside of a fraction or a decimal inside of a fraction. But this one here is just fine. So if you want to make sure especially that you get the correct fraction, you could put 1/4 times 3/4 into the calculator as the whole thing, and it'll simplify it for you. So if it worked out that it was, say, that this here was 1/4, the calculator wouldn't leave it as 1/1/4, it'll put it as 4. It'll actually simplify it down. Questions on this here? We good with this here? Yes? Do we need to see another one like this? So let's go on and look at this here. Yep. So let's see here. Got the feeling. Where are we at? Yes. Okay. Yep. I need to fix this slide because in your note sheet this says what? This is equal to y. I need to fix that because that's going to make a big difference. Okay. This one here is actually easy to tell which equation it is than having the vertex and the focus. Because the directrix is what? Y equals -27/2. Well, hey, look. Directrix is equal to? Okay. So it's automatically that one. That's the nice thing with directrix because y equals or x equals. It has to be one or the other. It just tells you. So this here, we're looking at the equation y is equal to 1/4p, parentheses, x minus h squared plus k. 4 parentheses, x minus, well, what's h? 5 squared. And k would be our -1. So whenever we're given the vertex, we're automatically given h and k. Now in the general equation for the directrix, it said y equals what? So the directrix is normally k minus p, yes? And for us, we know that this is equal to negative 27 over 2. That's just from the general equation, yes? Do we know what k is? Well, it's negative 1. We got that from the vertex, yes? Solve for p. And again, we could have plugged that straight into the calculator. It would have done it for us. We don't have to try to do that in our head. So p equals negative, yes, thank you. I am wanting to get way too far ahead of myself. Negative 25 over 2, yes, thank you. So p is equal to 25 over 2. Because again, we're dividing or multiplying by negative 1 to get there. And then we can take that in. Plug it back in. Because that would be 1 over 50. 4 divided by 2 is times 25. Huh? Maybe.
35 over 7 times.
That'd be a little tough, because I know the denominator is going to be 49. But the numerator would take me a bit. Questions on this here? How do we feel with this here? Do we want to see another one with vertex and directrix? Because I feel vertex and focus y'all feel comfortable with. How do you feel about vertex and directrix? The one we just did. We feel good with that? Because we can look at one more. Do y'all want to look at this one? Okay. So the vertex tells me the value of h and k. Now the directrix is y equals 73/8. It's y equals, because directrix y equals something is just going to be our y equals. Now if we're told the directrix was x equals, then we'd be looking at x equals 1 over 4p. Parentheses, x minus h squared plus k. Well, why don't we go in and plug in what we know. I don't know the value of p, so I'll just leave its parentheses, its spot open. Inside we'll have x minus h's value is our 8. And k is 9. Because again, the vertex is always going to be h comma k. So we have this here. Now our directrix, y equals 73/8. Well, the general form is k minus p is 73 over 8. Almost. So we plug in 9 for k. So we have 9 minus p equals 73/8. So, oh yeah, exactly. So we would subtract 9 from both sides, because 9 times 8 is, so we got what? Because 9 is 72. I think we probably get negative 1/8 if we plugged it in. So negative p equals negative 1/8. P is equal to just 1/8. Oh, yes. I see what you're saying, yes. Because the negative 9, or minusing 9, 9 is smaller than 73/8, because it's 72/8. So it'd be positive 1/8, which makes p equal negative 1/8. Did I lose anybody there? So we plug it back in. So at the front, y equals 1 over 4 times negative 1/8. Well, 4 times negative 1/8 would be negative 1/2, because negative 4/8, 4 divided by 8 is going to be 1/2, 1 over 2. And if we plug this in, we should get negative 2. And again, I would just type that in so you're not having to try to keep track of all of that in your head. Parentheses, x minus 8 squared plus 9. Questions on this here? How do we feel about these? Okay. Any other questions on vertex focus or vertex directrix? You like vertex focus, vertex directrix? So the real big thing is, again, as we saw, is just making sure we keep track of our signs. It's just the little steps, isn't it? And that we're matching it up correctly. Because if we do those, we'll get to the answer. Vertex focus, wait. What does this give us? Focus and, do we know what the vertex is? Okay, so let's, well, directrix is x is equal to negative 65/8, yes? Well, that automatically tells me what? X is equal to 1 over 4p parentheses y minus k squared plus, hey, it's going to be that equation. Because again, since the directrix is x equals, well, in the general form, that lines up with our x is equal to 1 over 4p times y minus k squared plus h. Because that's the general form of its directrix, yes? Now, looking at the focus for this here, in the general form, it is h plus p comma k, yes? Okay. Well, I don't know what p is, so we'll leave a space. Y minus, hey, I do know what k is. It is negative 7. So I could plug in negative 7, or it's the same as what? Plus 7 squared plus, do we know what h is? So in the focus, our negative 63/8 is h plus p. The directrix is what? So we know that h plus p is negative 63/8, yes? And we also know that h minus p is negative 65/8, yes? Wait a minute, I have two equations with two variables. We have to use systems of equations. We have to use systems of equations to solve. Now, when we normally encountered it, especially in the three variables where we had to decide with addition or subtraction, here it works either way. Because if I add the two together, well, what is p plus negative p? 0. Now, if I subtracted, well, the first one would be h minus h, which is 0. So if we add or subtract, we will eliminate a variable. And that will work with all of these. So we can go on and add. H plus h is p plus negative p. Well, that is Cancel out. Ooh. Now we need to take negative 63/8 plus negative 65/8. So 5 and 3 would be negative 128 over 8. Because the same denominator. Because it's almost, I think, if we put pizza slices into a box that are the same size, we still have the same number of total slices. Now, this will, well, they're both divisible by 2, yes? Why don't we simplify? So 128 divided by 2 is? Four goes into 64, doesn't it? So it actually worked out that those two added together is negative 16. It's almost like someone planned it that way. Divide both sides by 2, and that tells me h is equal to? So that means back up here, h is, but what are we still missing? P. So before I start erasing anything, are we good with finding h? We're good getting there? Okay. Now, okay, I'm going to have to write negative 8 back. Once more, there we go. Negative 8. Wait a minute, I do had, before we did elimination, we had two equations that were in terms of h and p, yes?
Yes.
Pick one of them. H minus p or h? We can pick either. So if I pick the top one, we plug in h, would be negative 8 plus p is negative 63/8, yes?
No.
So to find p, what do we need to do? Add 8 to both sides. 8 times 8 is? 64 minus 63 is? It should be 1/8. Because you could do negative 63 over 8 plus 8 in the calculator, and it should give you 1/8. So plug in the last term. X equals 2 parentheses y plus 7 squared minus 8. Now come ACT time, especially with stuff like this. Okay, I'm not drawing anymore. We're going to finish it tomorrow. Like this here, plugging in or simplifying something like 1 over 4 times 1/8, I would use the TI-30XS. I would use the yellow calculators. Because to plug this into the yellow calculators, well, we hit the fraction key, 1 over 4 parentheses, fraction key, 1 over 8, close parentheses, enter. And it'll pop it out. If I want to do the same thing on the graphing calculator, it's alpha y equals enter, 1 down, 4 parentheses, alpha y equals enter, and then plug it in. Which really isn't an extensively excess amount, but I could still plug it into the yellow calculator a little bit faster. For y'all, especially getting to some of the back problems, if it is a few seconds on each problem that you save, that adds up fast. Yes? Mm-hmm. Yes. Most likely on the ACT here, you could have both on your desk because it's really dependent on the proctor. Because if the proctor is staying strictly 100% by the textbook rules, they're going to want one on the floor, one on the desk. But if you're in a group, a big group, and there's one proctor and one administrator, they're not going to try to stick with the fact that you keep one on the floor, one on the desk. If there's 60 plus people. So, and even if they do get onto you, it's more just put one on the floor. That's about all they're going to say or should say. Okay? And most likely they will, especially if they don't iterate it at the start of the math, then I wouldn't worry about it. All right? So questions on this here. So we'll stop here for today because I know we do have another 7 minutes left of class. But what we're going to do tomorrow, because we can look at that, we're going the other direction. We're going to find the vertex, focus, directrix, and axis of symmetry from this. And I'm not going to worry too much about describing the transformation. But we're going to talk about how do we get the pieces back from this.